Hey everyone! Today we are continuing with compound probabilities. When we're talking with compound probabilities, compound means two events that are occurring at once. So for example, we could have a problem where you have a bag and they want you to draw a second marble out of the bag. So we could have a bunch of colors in here, some green, or some orange and some purple. So if we're doing compound probability, maybe they want the probability of getting a purple and then another purple. Another example is when you're getting dressed in the morning. Maybe you want to know the probability of pulling out a black sock out of your drawer and then pulling out another black sock out of your drawer without looking. Another popular kind of compound probability, which we'll get to at the end of this lesson, deals with cards. And they want to know what the probability of drawing two cards are or the probability of rolling two dice are. So we'll look at the dice example in a little bit. So there's two kinds of compound probabilities. The first one is independent events. An independent event occurs when the probability is the same for all attempts. And the key word here is they normally say with replacement or putting back the object back into whatever it's being drawn from. And when it's with replacement, that means that if the probability was a half, the second time it's still a half. So in this example, it says there are 3 blue marbles, 4 red marbles, and 3 yellow marbles. They want to know what is the probability you draw a red and a blue marble if you replace the marble after you draw. So if you're replacing it after you draw, that's your key that it's an independent event. And we'll actually look at solving this problem soon. The other kind of event is a dependent event. A dependent event means that the probability for the second attempt changes depending on what happened in the first one. And the key word here is normally without replacement. So here it says there are 3 blue marbles, 4 red marbles, and 3 yellow marbles again. But now it wants what's the probability you draw a red and a blue marble if you do not replace the marble after you draw. So here, what happens is if I get a red marble on my first draw, the probability is 4 out of 10 marbles. But now if I draw a red the second time, now there's not 10 marbles left because I took one out. Now there's only 9 marbles and 3 of them are blue. So my likelihood of getting a blue has changed from being 3 over 10 to now 3 over 9. So this probability changed because of the first event. So whenever we're not replacing, that means that our denominator in the second problem is going to change. So when we go to calculate these probabilities now, the rule for calculating compound probabilities is it's really just a multiplication problem. So if I want the probability of 2 events happening, we're going to write the probability of event 1 happening, the probability of event 2 happening, and then put a multiplication in between. So here's our same marble problem. And the first one said, what is the probability you draw a red and a blue marble if you replace them? So my probability of drawing a red marble first is 4 out of the 10 marbles total. Since I put the red marble back in the bag, that means that the probability of getting a blue is 3 out of the 10 marbles. And now when we're multiplying, we multiply straight across. So that gives me 4 times 3 is 12, and 10 times 10 is 100. So that's 12 over 100. If I want to simplify that, I can divide both of these. We'll start by dividing both of them by 4. 12 divided by 4 is 3. 100 divided by 4 is 25. So our probability is 3/25. If they wanted that as a decimal, we could keep going and we could go back here. That's 12/100ths or 12%. For this example, same marbles, but now it's the do not replace. So this is the one I did on the last page. The probability of getting red is 4 out of 10 times the probability of blue now is 3 out of 9 because that one marble is gone. So now that means our final probability, instead of being 12 out of 100, is actually 12 out of 90. And now this time we can divide both by 3 because I know 3 goes into 90 and 12. And that gives me 4/30. And it looks like that can go further. We can divide both of them by 2. And that gives us 2/15. So we can see the probabilities change based on if we're putting the marble back or if we're keeping it out. Now the next thing that we have is there are problems that will ask for the probability of rolling a sum. And remember, a sum means that we add the numbers. So it might say, what is the probability of rolling a sum of 12? And it's not easy to just multiply because we need to actually know how many ways is there to get a 12. So what I want you to do is, in a minute, pause this video, and you need to draw this picture onto your paper. And what I've done is I've created a sample space. A sample space is a picture that lets us create 2 events to see what all the possible outcomes are. So here I've already written in, if this is a 1 and a 1, that means this box represents 1 and 1. And since we're looking at sums, the sum of 1 and 1 is 2. This box represents rolling a 1 and a 2, so the sum is 3. A 1 and a 3 add up to 4, 5, 6, and 7. So as we keep going, now this is a 2 and a 1, so that's 3, 4, 5, 6, 7, 8. This is a 3 and a 1, so that's 4, 5, 6, 7, 8, 9. Hopefully you're noticing a pattern. 5, 6, 7, 8, 9, 10. That means this is going to be a 6, 7, 8, 9, 10, 11. And a 7, 8, 9, 10, 11, 12. So I want you to go ahead and pause this and copy this table down, because as you're doing the assignment and the quiz, they're going to ask things like find the probability of rolling a sum of 12. Once this table is done, you don't have to do any work. All we have to do now is look, and I see that there's only one way for me to roll a 12, by getting a double 6. So that means there's one way for me to get a 12, and total, if we count up all these boxes, there are 36 different sums that we could add. So our probability would be 1/36. So take a minute to copy this picture because it's going to be super important as you do the assignment and the quiz. So now there's 2 examples looking at this sample space. This one says, what is the probability of rolling a sum of 7? So instead of doing any math, we're just going to go to my chart. I find my diagonals of 7 and I look and there's 1, 2, 3, 4, 5, 6 ways to get a 7. So 6 ways to get a 7 out of 36 total. So our answer is 6 out of 36, or 1/6. So when you're playing dice games, 7 is a good number to bet on because it's going to happen probably the most because there's more 7s on this board than any other number. My next problem says, what is the probability of rolling an even sum? Remember, even are numbers 2, 4, 6, 8, 10, 12. So if we go look on our board, we need to look for all the evens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the probability of getting an even sum is 18 out of 36. And that actually simplifies to 1/2. So the likelihood of that happening is pretty good. You have a 50% chance of rolling an even sum. So hopefully this video has helped you, especially with problems like these. Like I said, I highly recommend copying this picture down. And remember, if you copy all these notes down and send them to me, you can get some extra credit. So I look forward to hearing from you all.